The normal probability distribution. So we have a typical normal distribution here. On the horizontal axis you have your data, for example heights or weights, time, anything continuous in nature. On the vertical axis we have the probability density function, and that's not the same as probability. It's the equation of the actual curve, which is very complicated for the normal distribution, so typically we don't use this equation for anything. We use the calculator's built-in statistical functions that will deal with this formula for you. And we can also use this formula here called the standardizing formula for problem solving. More on that later. The distribution is said to be bell-shaped, and you can see why. It is perfectly symmetrical. The mean is equal to the median is equal to the mode, and they are all at the center, this value. The shape of the distribution depends on the mean and standard deviation. So for this distribution, if I keep the standard deviation the same but increase the mean, the graph moves this way. If we decrease the mean, the graph goes this way. The total area under the curve is always equal to 1. So a smaller standard deviation will give you a curve that's taller and less spread out, but still has an area under equal to 1. And if standard deviation increases, the curve is more spread out, but it's less tall and still has an area under equal to 1. Probability is calculated by working out the area of a shaded region. And the distribution is summarized like this. So this is our continuous random variable. It follows a normal distribution, and that normal distribution depends on two parameters, the mean and the variance. And you might wonder, why variance? Why not just standard deviation? The reason we use variance can be demonstrated by looking at the height of a person who's wearing shoes. So the actual height measured will be the sum of the height of the person and the shoes. And if the height of the person follows this normal distribution and the height of the shoes follows this normal distribution, then you're expecting the combined height of the person and the shoes to be like this. So we can see that we've added the means together, and we've also added the variances together to get the combined total height of the person plus the shoes. When we add independent normal variables, we add variances together. We do not add standard deviations. This is why the normal distribution is given in terms of variance here as one of its parameters and not the standard deviation. So this would be totally wrong. Here I've got the mean and standard deviation as the parameter. So we would have this for the height of the person here, and this for the height of their shoes. And if we added them together, you can see that I'm trying to add the standard deviations together here, which is totally wrong. It has to be variances that are added together when we add independent normal variables. But this is not in the A-level maths course. This example just demonstrates why the parameters for the normal distribution are the mean and variance and not the mean and standard deviation, because the variance is far more useful when we have multiple normal variables. The normal distribution is the most important probability distribution in statistics. It arises naturally in many different settings, for example, heights of students, birth weight of children, IQ in various populations, errors in measurements, blood pressure, air pressure, travel time for commuting, and so on. These data variables are continuous and they go on the horizontal scale of a normal distribution.